In this video, we'll be talking about methods. The reason why I went over objects and classes first before even talking about methods is because we can only talk about methods in the context of objects and classes. I'll tell you why. Because everything in object-oriented programming languages, such as C#, is organized in classes. So all of our code is organized within the classes, either all in one class if our application is small enough, or it's chunked out throughout multiple classes, and then the classes interact with each other. But in any case, classes are the main containers. They are the blueprints where we have our code, and then those blueprints interact with each other. And that is how our application is organized. Now, what a method is, it is basically a group of statements that perform a process. That's all it is. They perform a process, and sometimes they return back a result, and sometimes they don't. For example, when we create our project newly, then we are given the default class, which is program, and then we have our method, which you already know is the entry point into the application, which is called main. And we can pretty much have all of our program within one class. It's not recommended, but you can. Or if you want to chunk it out within other classes, then you can have other classes which interact with program, and program interacts with them. But that's what I mean when I say that our code is organized within classes. So I'm actually going to go inside of the person class, which you can do by clicking on the person and then pressing F12, which is a pretty nifty shortcut once again. So I'm going to go ahead and create two methods. I'm going to say public int get age, and then return age. Then I'm going to say public void set age int new age, and then age equals new age. There you go. Now, before I go over methods, I want to talk about what the deal is with this underscore age, because you might say, where does that come from? And currently it does not exist. So I'm actually going to create it and then talk about it for a little bit. So private int age equals 25. Okay. So what is this? Because you thought we're only going to be talking about methods, and you're correct. But in this case, I'm introducing a new concept which we will be going over later down the line. This is called a field. So we can have fields, properties, and methods. Currently, this video is focused on methods, but as I said, I lightly touch upon fields as well. So a field, there's really not much to it. It is basically a data within our class. So you see, we have an access specifier, so we're saying it's private within the class. And if we can have different access specifiers. Once again, we can have public, which would mean that any other class could use this or would have access to it from outside of this class. But in this case, we're saying private, so it's only accessible within the class. And then we have the type for that field, and it is an integer. Then we have the actual name, and then we say equals, which is the assignment operator, and we assign a value to it. That's all. So we have this field, but now let's go over the methods. So let's go over the formatting of a method. First, once again, you have your access specifier. Is it public? Is it private? In this case, it's public, which means that any other class might access this method. And it's not just accessible within this class. So that's what this access specifier means. You can have access specifiers for your classes, for your fields, for your properties, and for your methods as well. Then you have your return type. Return type just says that this method will be returning a type integer. So it's going to process, it's going to do some stuff within the method, and then at the end, the result will be of type integer. Then we have the actual method name, which you can have it as anything, but just try to keep it as descriptive as possible. And then I can have parameters or no parameters at all. In this case, we don't have any parameters. In the case of the other one, we do have parameters. Only one parameter, but if you wanted to have other parameters, then you would just say comma and another parameter. So param2 or anything else you want, or any other type you want. This could have been a string as well, or anything else that you need to pass into the method for its processing. In this case, we only have one parameter. So it's int new age. Now, this first line is called the method's signature. So its access specifier, its type, return type, its name, and the parameters are called its signature. Then we have the body of the method. The body goes within the curly braces, and in this case, it's not really that complex of a method. It's just returning the age. That's what the return stands for. By the way, return is a branching statement. Remember how I was talking about flow of control statements and how there are three of them: conditional, looping, and branching? Well, return is a branching statement. Why? Because it changes the flow of the program. The moment you hit this, it will actually exit out the class and go to where it was called from. If we call it from the program, it will actually come right back to this class and continue execution from there. That's why it's a flow of control statement. And that's very good to know. Now in this case, I think it's pretty self-explanatory. We are calling getAge, returning the field that we have set here that's only accessible within the class. Then the other method takes a parameter from the outside and then uses the value of that to assign it to the field. So this value will change when we call setAge and pass in a new number, which is going to be the new age. Now let's go ahead and actually use these methods. So I will go to program, and then I will say person1 dot setAge. Actually, let's do getAge first, and then I will say person1 setAge, and I will say 29, and then I will say getAge again. Now we actually want to print these, so I will use console write line and print this one, and then I will use that again and print the other one, so we can actually see the values changing. And let me breakpoint here. Let me start the program. So you see, if I step over and step over again, you'll see that it says 25, right? But if I set age, and I will actually step into it so we can see how it steps into the method. See here? The age is 29 now. If we go here, this is 29 and this is 25, but it will be changed now. See, if we have over it, age is 29 now. I go here, and go here, and I print it, you'll see 29. So there you go. There you have it. But one word of advice about methods. So methods, as you already know, they're a group of statements that perform a process and give a value back. And sometimes they don't give a value back, which is why the return type is void. In this case, we're not returning anything. So the return type is void. And that's absolutely normal because methods don't always have to return things. Sometimes they don't want to return anything. In this case, it's totally acceptable. And that's why we just say void. So void just says this method won't be returning anything. But the other thing is that you want to keep the name of your methods very descriptive, and the reason why we have methods is so that we can have code reusability. Now, what is code reusability? That means that if we have a method that does something already, then we won't have to write that code again. All we would have to do is use that method from different places, and it would do the same exact thing that we want, but we'll only have that code in one place, which makes our maintenance a lot easier. Because if we want to change that method, we only change it in one place. And also, it keeps things very organized. And for now, that's it.